Hello friend, welcome to online lecture series. Today we will start unit number 2, applications of differential equations. In today's lecture, we will cover orthogonal trajectory. In last unit, we saw what is meant by differential equation, how to find its solution depends on the differentiable equation. If the differentiable equation is exact, non-exact, or in a standard linear form, or the differentiable equation in the Bernoulli's form, we study all such cases. In today's lecture, we will start what is the actual applications in the real life of differentiable equations. The first topic of the application of your differentiable equation is orthogonal trajectories. So first, we know what is meant by orthogonal trajectory. If two curves are intersect each other in a specific rule or some definite law, then the trajectory is formed, and such concept is said to be the trajectory. Two different curves are intersecting each other according to some definite law. This concept is said to be the trajectory of families. We will just move what is meant by orthogonal trajectory. So we already saw what is meant by trajectory. If two curves which intersect each other and their intersection angle is suppose 90 degree, then it is said to be the orthogonal trajectory of given families. The definition of orthogonal trajectory is that the curve which cuts every member of the given family of the curves at a right angles is called orthogonal trajectory of the family. For that, we will see an example. Suppose we have two different curves. The first curve is suppose these two curves we have. Suppose first is the parabolas. Y square is equal to 4 times x, in that a is one arbitrary constant, and second figure is the equation of your circles. X square plus y square is equal to a square, the equation of your concentric circle which is passing through your origin. If the parabola intersect to this particular circle, then what happens? Each and every member of this parabolic curve is intersecting each and every circle in some angle. If that angle is less than 90 degree, sometimes it is greater than 90 degree, sometimes the angle between these two curves is 90 degree, then the trajectory which is there is nothing but your orthogonal trajectory. So what happens when these two curves intersecting each other? Just we get this figure. The parabola intersecting the circle at a 90 degree angle, such a phenomenon is said to be the orthogonal trajectory. This is the concept how to find the two family of the curve are intersecting at a how much angle. Depends on that we are defined the trajectory of your family of the curves. It is either orthogonal or not a orthogonal. Orthogonal means the curves intersecting each other at 90 degree. If the angle between them is not exactly 90 degree, then that is not my orthogonal trajectory. So there are two different types of the orthogonal trajectory, depends on your equations. So how to find the orthogonal trajectory of the functions which are in the form of your Cartesian form. The Cartesian form in the sense the equation which contains xy with some constant. C is a constant, xy are the variable of your function. In this case, how to find the orthogonal trajectory of your given group. So, step number first is then we have to differentiate the given equation with respect to x, because x is my independent variable, y is my dependent variable, and only one constant is present. So we are differentiating the given equation with respect to x. After differentiating the given equation with respect to y, we get the new equation, and that equation is totally free from your constant. It means in the step number first, we are performing the formation of your differentiable equation, simply removing the constant. In the step number second, we have to change the derivative terms. The dy by dx is replaced by minus dx upon dy, and the new equation is occurred by replacing the value of your dy by dx in terms of minus dx upon dy. And lastly, we have to just find the solution of such a differentiable equation, and that equation is nothing but your orthogonal trajectories equation. Is it said to be the orthogonal trajectory? And when we solve this equation, we get the family of the curves. Similarly, if the equations are in the form of your polar, then what we have to perform? We have to again perform the same things. We have to just count how many constants are present in your equations. In this equation, only one constant is present. We have to differentiate the given equation with respect to theta, and removing the constant, we get a differentiable equation totally free from your constants. And in step number second, we have to change the value of your dr upon d theta in terms of minus r d theta divided by dr. Then the equation becomes phi times r comma theta comma minus r square d theta upon dr. This is the equation of your orthogonal trajectory. And lastly, solving this differentiable equation, we get the solution of your orthogonal trajectory. These are the two different ways to find the orthogonal trajectory of the given equation, if it is present in your Cartesian form or it is present in your polar form. We will see one example of this type. Find the orthogonal trajectory of the curve, and that curve is your x square plus cy square is equal to 1. First, we have to observe how many constants are present in this given equation. The given equation is x square plus cy square plus 1 is equal to 1 is my equation number first. We have to eliminate a constant c from this equation. For that, we have to just count how many constants are present there, so we can find the value of your c from this equation. Just shifting your x square to right hand side and the y square is multiplied to your c, the value of your c becomes 1 minus x square upon y square. So differentiating your equation number 1 with respect to x, we get the derivative of your x square is equal to 2x. The derivative of your y square is 2y, and again y depends on your x, it becomes dy by dx. And right hand side is the equation that contains 1, and whose derivative is 0. From this equation, we can take 2 common and just make the cancellation. So we get x plus cy dy by dx is equal to 0, equation number second. From this equation number 2, we can remove your value of your c. Means we have to put the value of your c from your equation number 1, and we are put in equation number second. After putting the value of your equation number 2 in your equation number 1, we get this x plus cy dy by dx equal to 0 is my equation number second. In that, when we replace value of your c, we get this x plus 1 minus x square upon y square is the value of your c, and y times dy by dx equal to 0. Simplifying this, y square and this y, one y get cancelled, we get x plus 1 minus x square upon y dy by dx. This is the differentiable equation of, after rearranging this differentiable equation, we get 1 minus x square upon y dy by dx equal to minus x. The next step, what we have to do? We have to just find the value for dy by dx. So dy by dx becomes minus times xy divided by 1 minus x square. Then we have to just replace the value of dy by dx is equal to minus dx upon dy. Before with that, we said that it's my differentiable equation of given family of the curve. To find the orthogonal trajectories equation, we have to replace dy by dx equal to minus x upon dx upon dy. After replacing the value of your dy by dx equal to minus dx upon dy, we get this differentiable equation. So minus sign is present on your both the side of your equation. So we have to cancel that minus sign. So we get dx upon dy is equal to xy upon 1 minus x square. Then this is the differentiable equation of the family of the orthogonal trajectory. We got the differentiable equation. And this differentiable equation is the equation of your orthogonal trajectory. Then we have to find its solution. For that, we have to just convert the differentiable equation into mdx plus mdy form, or we have to convert into variable separable. So converting the differentiable equation into variable separable form, we got 1 upon x minus x dx minus y times dy is equal to 0. The mdx plus mdy is equal to mdx plus mdy is equal to 0 form. This is the variable separable form. So directly taking the integration, we get the solution of this differentiable equation, and we can find the differential equation solution by integrating your m with respect to x, n with respect to y. So there integration of your 1 upon x is log x, integration of your x is x square upon 2, and integration of your y is y square upon 2, and making the multiplying this solution by 2, we get 2 times log x minus x square minus y square is equal to 2. According to index rule of your logarithm, the log of x square minus x square minus y square is equal to c1 is the solution of your differentiable equation. In a similar way, we can find the solution for the polar form. For the polar form, we will see the second example. The example is here. The example is given, that is r times a in bracket 1 plus cos theta. The given solution or the given equation that contains one constant, so we have to differentiate the given equation with respect to theta with respect to 1 times. So we got the derivative of your r is dr upon d theta, and a remains constant. Derivative of your 1 is 0. Derivative of your cos theta is equal to sin theta. After multiplying a to sin theta, we got dr upon d theta is equal to minus times a sin theta, and finding the value of your a, we get the value of your a is equal to 1 upon sin theta with minus sin dr upon d theta. Replacing the value of your a in your equation, so we got r is equal to minus times 1 upon sin theta dr upon d theta 1 plus cos theta. This is the value of your a. We are replacing the value of your a in your equation number first. So multiplying 1 upon sin theta to your bracket 1 plus cos theta, so we got r is equal to 1 plus cos theta upon sin theta dr upon d theta, and just making the changes, which is the differentiable equation of the given family. Replacing the value of your dr upon d theta by simply minus r square upon d theta upon dr. So replacing the value of your d theta upon dr upon d theta with minus r square d theta upon dr, we got this minus get cancelled, r square and r get cancelled, and we have to shift that r to the left hand side. So it becomes 1 upon r. 1 upon this r minus n get removed from both the sides. Then we have to shift this r square to your left hand side. It becomes r square upon r. It means 1 upon r. And 1 plus cos theta upon sin theta. Then 1 upon r, variable separable form. 1 upon r dr, 1 upon sin theta, cos theta upon sin theta, d theta. And we know that 1 upon r, as it is, 1 upon sin theta is equal to cosec theta, cos upon sin is equal to cot theta. Variable separable form. Directly taking the integration, we get the solution of the differentiable equation. That is 1 upon r integration, cosec theta integration, cot theta integration. 1 upon r integration is log r. Again, the integration of your cosec theta is equal to log of cosec theta minus cot theta, plus the integration of your cot theta is equal to plus times sin theta. And we are just taken the constant of integration as equal to log c. And according to the rule of your log, we have to just multiply the addition of your log a plus log b. It becomes log of a into b. Then this cot sin theta is multiplied to your cosec theta and cot theta. And after simplifying, we get a final solution, that is a log r is equal to 1 minus cos theta c. Taking exponential on the both the sides, and we get a final solution, that is a r equal to 1 minus cos theta into c. It is the solution for the differentiable equation, which is the solution of your orthogonal trajectories equation. So, thank you.